Good morning, good afternoon, and good evening. Thank you so much for joining us from wherever it is that you are. My name is Michael Thiesmer, the Executive Director of the U.S. National Artificial Intelligence and Cybersecurity ISAO. I'm an independent consultant, board advisor, and chairman of the UN AI for Good Innovation Factory Baltics. I have over 20 years in various Silicon Valley information security and technology roles and worked with companies large and small. I owned all consumer-facing technology at Sony PlayStation during the PlayStation 4 launch, and in fact built the launch model and was a leader in the control room. I have also helped shape international cybersecurity standards, advised the US government, NATO, and the UN on matters involving cybersecurity and AI, and led multiple startups from inception to successful billion-dollar-plus IPOs. This means I've not only seen how technology and cyber threats have evolved, but also faced the challenges of combating them daily. Today, I will be your host, and thus, on behalf of the Tor Breda Institute and the NSE ISO, I would like to welcome you to this roundtable session on AI and cybersecurity for a safer digital world. Before we get started, we want to share a little about the Tor Breda Institute and the NSE ISO. The Tor Breda Institute was created to promote collaboration across public and private sectors with a focus on business, culture, and diversity. We're looking to reshape and develop collaboration on partnering practices with a view to improving and securing businesses and economies. The NSE ISO is an NGO and public-private partnership focused on exchanging cyber threat intelligence, cyber diplomacy, cyber capacity building, research and development, national policy advisory, and go-to-market strategy. Today, we run programs on 3 continents. If you're not currently a member of the Institute or the NSE ISO, we invite you to visit our website to learn more and see how you can participate. As we dive into this conversation, I would like to introduce you to our panelists, Dr. Schaffer-Ramsey and Colonel Stoney Trent. Dr. Schaffer-Ramsey, I would love for you to introduce yourself.
Good morning, good afternoon, wherever you are. It's wonderful to be here. Thank you for the invitation. I have a PhD in artificial intelligence and about 20 years experience in the field, several patents and inventions that involve both cybersecurity and AI. And I have over 25 years experience in cybersecurity. And I've worked in nearly every aspect of the field. I've built many companies, quite successful companies. And I've also collaborated with the U.S. Department of Defense and other entities within it. And I'm happy to be here, and I'm looking forward to the conversation.
Glad to have you, sir. Colonel Stoney Trent, sir, please.
Hi, I'm Stoney Trent, former Army Intel and Intelligence and Cyber Warfare Officer. I'm also a cognitive engineer, which means my research focuses on the interaction of people, technology, and work. I lead research at my company, the Bulls Run Group, as well as serve as a research professor at Virginia Tech, working on trustworthy AI and human-machine teaming concepts. When I was on active duty, I had the good fortune to establish and direct an experimentation lab for U.S. Cyber Command, and designed and helped to stand up the Defense Department's Joint Artificial Intelligence Center, which is now the Chief Data and Analytics Office. Currently working as a co-principal investigator for a cybersecurity program under IARPA, the Intelligence Advanced Research Programs Agency, called RESCIND. And I'll talk more about that a little bit later.
Awesome, great. So the audience, if you haven't figured it out, we actually have a really good panel here. Very much looking forward to this conversation because we're getting a lot of different perspectives in this room. I think we can all agree that we have a rapidly evolving digital landscape, and the intersection of artificial intelligence and cybersecurity is not only increasingly crucial, but it is absolutely crucial. So, audience, we will basically now explore how AI technologies are revolutionizing threat detection responses. We'll discuss some of the emerging threats and innovative solutions, and we'll underscore hopefully the significance of the collaborative efforts across various sectors that exist to kind of help us secure our societies. So, gentlemen, like I alluded first when we had the chance to sync up earlier, AI and cybersecurity have this relationship where they affect each other. I mean, obviously, like most technology works in this way. We have cybersecurity that helps secure AI. We have AI that helps make cybersecurity more secure. We have AI being able to be leveraged for defense, for offensive tasks. So basically, we can say we have to look at both a role as a threat or at the current threats, as well as how it integrates and makes detection and defense better. So why don't we start with the threats? Let's discuss a little bit what new threats exist currently and which threats are emerging, and how basically AI helps these threats or threat actors be more efficient at what they're doing. I don't know who would like to take this question first, but I'm opening it up.
Well, I'll offer some thoughts, and Schaefer, feel free to build on any of them or counter them. What we're seeing is the emergence of AI systems is creating additional targets for threat actors. AI systems themselves are complicated pieces of software that run even more complicated mathematics in the background. Their models and training data repositories, and even the extent of their AI development pipelines are very attractive targets because of the features that and the investments that go into delivering AI systems. Infecting these supply chains can create widespread vulnerabilities across customer bases, and these vulnerabilities can go undetected for as long as the system's in operation. So we see this as a call for more attention that needs to be paid towards AI testing. This includes not only security testing of these development environments, which are widely have typically widely been sort of undersecured, treated as research environments or sort of sandboxes that for academic purposes, but also the testing of those the computational testing of the models and data. And the third style of testing that these AI systems warrant is the human-machine teaming testing. And what I mean by that is investigating the extent to which the systems support or don't support work in the real world by the human users. How are they adding to the complexity of the work that they're supporting, and how are they therefore then creating unforeseen or undesirable changes to workflows, perspectives, and decisions at the human layer of the technology stack.
Absolutely.
Schaefer.
Wonderfully said. Thank you for that. That was a great summary of the environment that we find ourselves in. AI has been used in the offensive world for a long time. Predominantly right now, it's being used to make spear phishing more effective. There was a recent study that found that AI enhanced spear phishing resulted in the same level of success for the adversary as an experienced adversary using the best tools and the best language and the best methods and expertise on the targets that they were going after. So it's comparable to the best that human beings can do now. And that's what it's doing right now. Now, this is important because the Bilal study shows that 90% of all enterprise network penetrations are occurring through email. My own experience has been that recently I was refreshing a course on penetration testing, and the teacher said at the beginning of the class, forget about any other way to get into a network other than spear phishing, because everything else is just so locked down right now. And so, from my own anecdotal evidence, but also from the Bilal study, we have this data point, if you will, that spear phishing is a great way for bad guys to break into networks. Unfortunately, AI is being used right now to help the bad guys get into networks via spear phishing with greater and greater success. And the good news is that AI is also being used for defensive purposes to detect spear phishing. There was a really interesting study, and my own dissertation was on that. There was a really interesting study that found that with about a 95% success rate, using only 20 to 25 ish words, AI that was bidirectional could discover and identify, properly classify a spearphished email, a malicious email. And so that's encouraging news. We have a long way to go, and we are locked in an arms race with the adversaries.
So I just want to say I absolutely love what both of you said so far. This shows actually the quality of the panel, because number one, Stony, on your end, the fact that you already touched on the issues when it comes to securing AI and like how adversarial machine learning and attacks can directly target the AI, I think is something that a lot of people originally thought of as an academic exercise. Like, adversarial machine learning, that's like a thing that is not really happening yet. Like, we don't need to worry about it. And then the world accelerated dramatically, and we're now in a different type of reality. The other piece is just the wealth of direct practical experience. I see exactly the same thing. People are worried about this like direct attacks against network perimeters and all this kind of stuff because that's what the movies show, right? And it's not that this isn't happening, but the cost of that and the effort is so much higher. The reality is spear phishing is almost always the way in. And I think the IBM data breach report, the IBR, identified that in I don't know what it was, but it was a vast majority, maybe 70%, 80% of attacks involved actual valid accounts, right? Account compromise. So not like some breakout scenario or whatever. And people, I don't think, realize that's the case because they're like still thinking more on like layer 3 type technology and those areas. Now we covered a lot of ground already here. I wanna dive in a little bit into like some of the composite topics that we discussed. When we are discussing targeting, right? I think that's something as well. If I'm a target planner, I have a target pool. Stony might be familiar with this type of language. And at the end of the day, it's an ROI calculation. What moves into that pool or what moves out of the pool. So even here, I think AI, because of how it enables me to do OSINT better, because, I mean, let's go back before we called it AI, machine learning, data science, big data, right? It helps me make better decisions based on data sets. It helps me work better with data. And if I can go in and do all this kind of work before I start an attack to identify valuable targets, automate reconnaissance, that itself, I think, enables big things. Now, on the spear phishing part, I was wondering, has anybody here seen the use of psychometric profiles to enhance the ability to spearfish? Because I see in marketing tools where Gen AI is being used to do outreach, I've seen that. You're purchasing of decision makers like these psychometric profiles, and it is scary what's in there. Like it's so much detailed information. Is there anybody like concrete like evidence or like seen this being used in the wild?
Absolutely. If you don't mind, I'll jump in on that one. I've done it myself as part of research. There's some really wonderful techniques in OSINT. For example, let's take it in two steps: OSINT and then psychometric research. In OSINT, we've got I've built multiple models and systems that will go out and scan the internet in clear, deep, and dark web, and they are able to scan thousands of websites, consolidate it all into one data corpus, plow through the data corpus, and then you can ask the data corpus in plain, simple English, and get plain, simple English answers back. And that'll help you identify your targeteering. Your targets are most likely to click on this, that, or the other, and how they are most likely to click on it, why they're most likely to click on it. And here's the scary part: it can do it in 25 seconds. So it would take a human being and typical targeteer, no center, dozens of hours to perform that sort of work. But the AI can pull it out, go to 1,000 web pages, pull it all down, plow through the data, come up with a list of targets, and it can do it in about 25 seconds. So that's the OSINT capability that exists right now that I have personally developed. So there's got to be better than that in the world. So the second thing that you asked is psychometrics, which is really interesting because using the same sort of work, same sort of information, you can identify people that are likely to click on things. I'm starting to stutter because I'm trying to figure out what I can talk about and what I can't talk about due to NDAs and whatnot. But let me say it this way, that there are plenty of people that are working it right now that are able to figure out if you are most likely to be in the market for a Ford F-150. And if so, what is going to entice you to click on an advertisement for a Ford F-150? And if they can do that, they can do other things that are malicious.
Absolutely. And then it used to be the task of trying to sound like somebody as well, right? If you're pretending to be somebody in BEC, that used to be something that people had to do manually or were using like bad models for. Now, with what we have today, I would imagine even that is a short task. Stony.
Oh, yeah. I want to just build on a little bit that Schaefer was describing there. This notion of AI generating phishing content we're seeing both in research projects and even just the operations of our small business. Evidence of this is widespread. Very realistic, not only very realistic spear phishing emails, but now pairing those targeted calls through the use of bots to text messages and phone calls. So the cyber domain is now being shaped and attacked via other attack vectors. They're utilizing robocalls to set and even voice, which may only result in a voicemail message or a text message. But they're using those to set the conditions for cyber attack vectors. The important part of this is that it's not just generic spam. It's very targeted, highly tailored content that is clearly scraping information that's publicly available, as Schaefer's mentioning here. And then automating the targeted messages to be most effective. So the preponderance of publicly available information on people and organizations is creating a dynamic where it's a very straightforward utilization of large language models and some automated voice tools to generate complementary attacks. We're actually supporting an Air Force Research Labs project right now that's looking at influence tactics on adversaries, and this is kind of complementary to a second research project that I mentioned for IARPA. But in these projects, what we're seeing is that a significant amount of evidence supports prior studies in cognitive and social psychology that show that the context in which messages or influence tactics are delivered matter a lot. If you see a car on the street, it's nothing new. If you see a car in your backyard, it's something special and unique. And so the ability for these automated messages to be timed with things that are occurring in the real world, election cycles, tax filings, debt notices, filings for mortgages. These are things that become publicly accessible through these automations that allow them to create very tailored messages that in highly engaged workforces have an impact. I think that this is a tremendously significant evolution in cybersecurity, where information that's available widespread outside of your information system becomes useful in creating these attack vectors on your information system.
Yeah. I think what I want to drive home to the audience here is usually when people like us meet and we talk, people were used to that we speak about things that are in the future or kind of like these emerging, far, far out things. A lot of what we talked about right now is happening and has been happening since over the last year or two plus.
Mm-hmm.
Like people are talking about deepfakes. If they're not involved with this, for a lot of people, this is kind of like, oh, an emerging thing. I don't know whether any of you remember this, but I think it was last year, November, the case where a deepfake conference call was done with a fintech company, and the CFO wired I don't know how many millions of dollars because he thought he was talking to the CEO. People think like, oh, well, who would go through this? Well, if it's a multi-million-dollar payday, it makes absolutely sense. And AI enables you to curate information and create this tailored content where the ROI totally justifies whatever it is that you need to do in order to get to that multi-million-dollar payday. And I think in this case, it was actually a huge payday. I forgot what's 40 mil or something that got wired somewhere. Whether they got it or not, different story, but still. And the other thing, of course, this overlap, cybersecurity, cognitive warfare, and information warfare. This intersection with AI, everything overlapping, and with that, bringing up threats that we traditionally speaking don't see as cyber threats, but they're societal threats, and they're driven and enabled by AI. I think misinformation is a massive item here, and it can be used in order to support cyber attacks, or it can be used for entirely different kind of effects that you want to have on target population, this kind of stuff. There's one thing, maybe Stony might know something about this, but 2018, I had the questionable honor of being part of a delegation trip to Wuhan, China. It was for the International Standards Organization. It was probably one of the few times that a US delegation that included a bunch of cybersecurity people and ex-government and current government cybersecurity people was on that type of official trip. And it went to the NSCC. I forgot what they call it. It's a National Security Technology Complex in Wuhan. This is where they hosted it at. And I remember back in the day, people were saying like, okay, China is graduating all of these cyber operators. Like, I forgot what it was. I think at full capacity, that center is able to do 40,000 a year or something like that. But we would always say, well, quality beats quantity. They have 40,000, but how good can they be? But now, if we're adding to that the effects of LLMs, generative AI being able to support, how much power projection can this mass of, let's say, 40,000 operators actually produce? I think this is something that we need to consider as well. Maybe anybody would like to elaborate on this.
If you don't mind, real quickly, I'd like to point out that there's a program. You can see it on Wikipedia. It's very public in what they're doing, and it's called A Minor, and it stands for academic minor. And what it does is it tracks as much as it can everything about everyone, so that they can identify who is in leading what thought groups within academic research. And that's just one example of a data source that is ripe for the taking for an AI, and I'm sure is being plundered by AIs. And the other thing that you mentioned that I wanted to point out is Stalin's quote that quantity has a certain quality all of its own. And then Stony, I'll turn the mic back over to you.
I guess the first thing that I want to clarify is that your trip to Wuhan did not, in fact, generate the propagation of the COVID virus. You want to clear up. You did say it was 2018, right? So
it was 2018.
Maybe you were responsible for COVID-18. I think that I take a more sober approach or perspective to China's investments. I think that's what we're really, discussing here is, what are the sort of, strategic implications for these massive, and they are massive investments, by China in AI systems, in AI workforces, in cyber workforces. They do represent a high prioritization by the Chinese government, because these are government orchestrated things, even sometimes when they're sort of advertised as Chinese corporation investments. But the reality is that total investment in advanced technologies is rarely an indicator of ultimate success in the global security arena. That we've seen time and again in previous innovation episodes, technology innovation horizons, where advanced technologies were in the hands of the losing parties. And what I've advocated, and I have an article that I wrote a couple of years ago that kind of summarizes some of these perspectives in the national interest, the publication, the national interest, is that what we actually have, what it actually creates, is the opportunity to make better, smarter investments in cyber and AI, because smart investments are winning propositions. Massive investments can oftentimes, overturn your economy. We saw this in the Cold War arms race, for instance, in which both parties invested massively. One party smartly, the other party not so smartly, and the Western economies prevailed, not just because of their technology investments, but their overall management, or sort of lack thereof of management of an ecosystem of innovation that encourages learning in a distributed marketplace. That encourages massive small scale innovations or innovation attempts, rather than centrally orchestrated government investments. So I think that what we're actually seeing here is the early stages of a similar arms race, in which there will be inherently massive advantages to making some large leaps in stealing technologies from the West and implementing them in ways that the West finds unacceptable, because of their impingements on civil liberties and privacy, and ultimately those attempts will fall short. So I don't think it's something that should be entirely downplayed, but I think that there are many that sort of utilize the wrong metrics for our adversaries to make investment decisions, suggesting that we ought to match them in dollars and numbers of people, rather than matching them rather than overmatching them in wise cultivation of innovation ecosystems. Because this is what's gotten the West to where it is innovation ecosystems, not massive investments in dollars and individual people by the government.
Absolutely love what you said. We innovate, they replicate. It's a sentence that has been said quite a bit actually lately. Okay, so obviously we discussed threats, but we will move now a little bit more to the defense side. Now, one thing that I used to often say is, before you can walk, you got to learn how to crawl. Before you run, you got to learn how to walk. We're talking about AI and defending AI. There's the obvious task to secure your technology stack itself. Lots of companies are still struggling with the asset inventories and basic vulnerability management. Yet they are trying to get like the most shiniest, toy on the market, because they are worried about possibly rightfully so, like some of the AI-based attacks that we just were talking about, or some attack directly against a LLM or the data that an LLM, the models, or whatever else. But let's talk a little bit about how AI is today integrated into cybersecurity and how that might change going forward from now on. Anybody that would like to take the question, go ahead.
So that's really a great subject, and we could probably have an entire panel just on that. The first thing that I want to think of and I would talk about is the defense of code. So code in and of itself is reversible. It takes time, takes effort, takes energy. AI is getting much, much better at reversing it to figure out where the holes are, but AI is also getting really great at defending it. I have a patent, not to talk about just what I've done, but I have a patent that defends code and uses AI to do so. And it's a very effective patent. It was granted an unprecedented perfect score by the Patent Cooperation Treaty. So AI is used in creating defensive structures that are very effective at defending code and detecting when code has been altered and detecting when code has been manipulated or affected. Stony, what do you have? I don't want to monopolize the conversation.
So where I think the larger topic here is, that where do we see AI, impacting threat detection and cybersecurity writ large? I think most of the audience here, recognizes that there isn't a cybersecurity commercial cybersecurity company that has not adopted some or advertised some AI features in what they're offering today. It's sometimes questionable whether whether it might actually include AI or not. They won't ever prove it. But ultimately, these features, are being used to improve pattern and anomaly detection. The implementations that are focused on pattern and anomaly detection are analyzing network data and host data to improve the detection of malware, indications of compromise, and even helping administrators with configuration management, identifying and patching vulnerable applications, just as Schaefer is kind of indicating the ability to improve or patch code in an automated way is dramatically helpful. These are all great things. The downside that I see to the current landscape is that the vast majority of these have been implemented as black box features.
Yes.
And they're doing them for good corporate reasons. I'm going to protect my intellectual property by not telling anybody what it does, and you just have to sort of trust the outputs. The notion of the customer or the users interacting with or even having any understanding of the information processing is not really in the architecture. It wasn't intended for, under the business model that grabbed so much venture capital. The problem with this paradigm is that it isn't well addressing the changes in cognitive work of the security analyst or operator. The notion is that we're transferring through these AI-enabled systems the responsibility of the network protection back to the original software team that wrote the application. And so you don't have to worry about it. We have it covered. And we're seeing evidence where this isn't a helpful construct, that the bill payers for the cybersecurity applications failures are the customers, are the users. Those are the individuals that will spend their nights and weekends recovering from the failures in the cybersecurity application. when when it's realized. It isn't the software developers that are nowhere to be found, or that are the vendor that's protected in the terms and conditions of the software license. So what I believe we'll find in upcoming years is this where the initial demand from the market was for automation to support these sort of low level, or we'll call them low to mid level protection measures. I think the market will soon demand levels of observability and control, or directability in these cybersecurity applications that has not been engineered into the earlier generations of AI-enabled systems. This will be the stage in which you will find more resilient human-machine work systems, not just technology that's expected to operate autonomously, but truly treating the system as a human-machine work system that retains a sense of agency by the human operator, and allows them to make recoveries when they're appropriate. So I think that, again, we're on this sort of we've been on this sort of hockey stick growth approach in AI-enabled systems, but I think as the market plateaus out, as we realize the performance limitations of some of these AI-enabled systems, there will be a return to a desire from the market for better control and knowledge about how the systems will work and won't work.
And inherent in every AI is the hidden layer. And the hidden layer is hidden. It's called hidden for a reason. It's almost inexplicable how the nodes will interact with each other as they're stimulated to produce the output that they're producing. So explainable AI is a target in the market these days, but it's very difficult to do because you have to overcome the hidden layer. So when you're looking at things like supply chain interdiction and the difficulties that presents in ensuring that your code is accurate, complete, and then you have embedded in your production line, you have the hidden layer that's there. Well, now you really have two things you have to look at, and they're both very difficult to defend against. These things are really fascinating from a research perspective, but they have real world consequences. For example, AIs can be built so that they are blind to a specific thing. And so the experts that are counting on that AI to look for that specific thing come to the conclusion incorrectly that the thing is X when it's really Y. And that's a today technology.
Yeah, I took a class in 2016 at Harvard. I wished I was remembering the professor's name, but even there, he already basically came up and just said that the black box problem is going to be really difficult to solve for us, and that is truly where we will find, if we solve it, the biggest how would I say that, the biggest positive impact for our operations or for what we're doing. He used a national security type of scenario. I think he was an undersecretary of defense at some point, and it was more based on like country B is preparing for a first strike. The data set, basically, that's what it's saying. You are using some AI solution, future AI solution. That's what you're getting. You're the poor Intel analyst that now has to take that docket and walk into a room and say, based on what I have, this is what it is. And how do you build this confidence, like where you would actually now recommend a course of action or even dare to step into the office of your superior to say, hey, they're about to attack us, we got to hit first. Our problems here are a lot smaller, more day to day when we're talking about a cybersecurity context for like a normal company, but it's still the same thing. How do I justify to my CEO that I need to take something offline if I don't really understand what actually happened or how the tool came to this particular conclusion? I might get some part of the story, right? I'm sure we all might have used an XDR or a SASE solution. Most of my clients use something like that, but it's still limited context. It's going to tell me like, this is the type of attack that was detected here, blah, blah, blah. But then unless I want to go in and start, I don't know, doing again like process analysis, basically act as if the AI didn't exist and dive through the entire data myself, well, then I won't be able to come to a conclusion. I will not have this context for myself.
And all the
Okay.
advantages of using the AI go away. The
Yeah.
time saving, the efficiency, the ability to quickly come to a conclusion that's accurate and complete goes away. You reminded me of a use case where AI is being used for deception detection, and it's amazingly good at it. And when it's a clean AI, but when it's a AI that's been changed, deception detection becomes faulty. And yet the people that count on it for deception detection still trust the answers.
Yeah. This is one thing, like I actually have a patent related to polymorphic defense. And it's a similar thing, right? We now have security data lakes that is a wealth of information about threat-based information, system-based contextual information, user entity behavior analytics, all this kind of stuff. And you can use this to drive very great automated decisions even when it comes to like configuration changes, like moving things around in network segments, hiding the treasure, and all this kind of stuff. But I mean, the problem with that is you're trusting that the
Yes.
data hasn't been poisoned, and you're trusting again a black box AI, because trying to reverse like why XYZ was done is going to be nigh impossible based on the size of those data lakes and what the model is using. Stony, I thought you wanted to say something.
Oh, well, I was just going to say a lot of what I think has sort of encouraged this trajectory is this sort of misleading notion that cyber decisions and actions have to happen at the speed of electrons. And this is actually very unhelpful a way of thinking about activities in cyberspace. That yes, packets flow at the speed of electrons, but decisions, attacker actions, decisions that the attacker's making, decisions that that need to be made by the defender, are typically made at human scales. That they're made in hours, months, days, years, rather than instants. And when you're designing your technology solutions with the notion that you have to make decisions at a pace at which no human could possibly intervene or have any knowledge about, you're already setting up the operating concept in a wrong-headed way. We are running a series of experiments right now in which we're studying hacking behaviors and reasoning, and these are expert hackers. These aren't sort of hobbyists. These are highly qualified hackers from all over the world. And what we see is very deliberate planning, methodical actions that take place even under the best circumstances. A loosely controlled experimental environment with guided tasks. Things take a while, and so the notion is that should be for these technologies that it's okay to design a system that is observable and directable by humans. What's not okay is the premise that your technology will operate in a feedback loop or an action cycle that is going to be beyond comprehension, because it'll create problems that you have no way to get out of. There's actually a good article about this, in a non-cyber domain, but we're going to bring it this. There's a good story developing in Israel with AI-enabled targeting systems. There's been a couple news outlets that have highlighted this story of the utilization of an AI algorithm to identify targets. The fact that the way the system was designed is to generate any number. So it could be infinite almost, but a high number of targets based on available information, and queue them up for a human to decide whether or not to service the target or not. The reality of the system is that it's been generating so many target recommendations that it becomes impossible for the human that still has to click yes, but it's creating this human machine work system incentivization to say yes. So in other words, you're just sort of giving you're creating the illusion of a human operator by creating so many target recommendations. And you can imagine this happening in a cyber security operations center as well. It happens daily, in which there are so many recommendations for so many actions that the humans are unable to direct the system in an efficient way. And this is causing problems on the battlefield for Israel, with targeting decisions that they may not necessarily have wanted to make if they would have thought them through more detailed. And it happens today in SOCs worldwide as well.
Yeah, there's a study out a couple years old, but it's still, I think, valid. If anything, the conditions gotten worse. But it was the Zhao paper that says that it boils down to a 100 gigabit network. You have essentially 53 milliseconds of latency to make any decision on. And so when you're trying to determine, detect, investigate, and execute solutions to problems, and you've only got 53 milliseconds to do it in, you've got to use tools to work with that. And then what happens with the human being? They just get overwhelmed by the speed that they're expected to operate at. And so I think there is going to have to be a social mechanism in place that allows people to be people and to take the time it takes to make the right decision.
And I think one of the ways that you'll see CISOs and security engineers start to come to grips with this and accommodate it is through again, treatment of architecture as part of the solution rather than just the cybersecurity tool that you deploy at the edge or on your host or wherever. We've been talking about treating cybersecurity as more of a soccer game than a football game, or something. We talk about this in the cyber operations force in the military. It's not just about offense and defense. You have to be able to play both. But if your technology and to include your system architecture doesn't allow for you to play soccer, if it doesn't allow for you to have to accommodate, and what soccer means is the ball sometimes comes to your side of the field, and that's okay. You don't have to stop everything at the firewall in order to succeed. But you have to have mechanisms throughout to allow you to understand where the hacker is going. And it's okay to acknowledge that there are attackers in your network. You're going to make decisions at a human scale that will be best for your organization as well as the operation of that information system. And I'm glad that you brought that article up, Schaefer, and if you wouldn't mind sharing that with me too, I would like to use that. I think that's a great example of misusing, an inference about, in this case, the cyber work domain.
Absolutely. I'll send it to you.
Well, definitely some good learnings here, that's for sure. I hope that private industry can have this dialogue. I can see in some sectors like e-commerce, for some companies that I'm aware of, like the one primary metric that was always being used for anything that impacted the cloud environment and the application was website downtime. 1 minute costs us X multi-million dollars, whatever it was. And that was it. That garnered everything. So anything that basically made this metric worse was immediately getting executive attention. And then, of course, consequences assigned for that, which even affected like simple things like let's contain something, right? Sometimes on human timescales, like, no, we're not going to do that. We're going to continue run when we may not, when maybe we shouldn't be running right now because of some other considerations that have nothing to do with cybersecurity. and that is my merge towards ethics. I love that today we started discussing the human component. I think when we talk about AI ethics is a incredibly important topic in the national security context, societal context, like pretty much in every context that you could be discussing this, because it does consider the human component. And like we discussed earlier, or I think Stoney, you brought this up, some of the technologies that will be in AI enabled will not be acceptable to be used in a certain way in Western society because they are too much infringing on personal liberties. So when we discuss AI ethics, let's frame the problem. Who wants to just frame the general problem first at a high level, and then we dive like into details as it relates to ethics and AI models?
So I could give it an attempt and by using an example. Recently, I was loosely involved in a law enforcement case. They were trying to determine deception detection of the many different witnesses that they had in the case. It was a very important case, and they pulled in the best folks that they could. And eventually it came down to a 50-50 toss-up between two witnesses, both telling different stories. Neither one of them could have been true. And so they brought in an AI, and they used that AI to detect deception by picking up small signals. That is great when it's a clean AI, but it's lousy when you work in an environment, maybe it's because of governmental laws or whatnot, that require that the AI be blind to certain persons of influence. So when it involves that person, then the AI must produce a different result than if it would just any other person. And that's an ethical case that we've yet to approach or even begin to define or put boundaries on. And yet it's happening quite frequently. What do you do when you have the truth about people that are extraordinarily powerful? And how do you approach revealing that truth? And then how do you justify the truth when you can't really go back into the hidden layer and say, well, this is the reason why this weak signal was pulled out. And this is the reason why this weak signal is the truth.
That's an example.
Yeah, just throw. I think the AI ethics, or to me is popular. It's a popular discussion point these days because AI is sort of sexy and in the news and things. To me, it's about ethics in utilizing technology in an ethical way. It's any technology should be used ethically. So it's a matter of what ethics you're adopting. One of the challenges for AI enabled cybersecurity tools, I think, is that we've seen some significant improvements in the areas of insider threat detection. It's there's some very good commercial solutions right now, and they've been around for at least 10 years. That they monitor host and network data and identify unusual workflows and in order to indicate where your potential insider threats might be in your organization. This might be monitoring key logs, it might be monitoring file accesses or login attempts, or and it can be very. There are some of these efforts. Some of these solutions are very nuanced, very finessed. The downside is these, and I think this is a little bit of what Schaefer was getting to, is that monitoring capabilities are often these types are often fielded by organizations and then hidden from their workers, and this is where we create cultures of suspicion, and it can even be worse in the fact that many workplaces have contracted workers or maybe union employees that have terms of employment that don't actually accommodate these types of monitoring. Schaefer was kind of thinking of sort of, I think, special classes of workers, and that's, I've kind of tried to highlight a couple of those classes of workers that may not be monitorable, and yet some organizations, are attempting to, either sell or acquire these tools to monitor them. And I'm not saying this to suggest that we shouldn't actually have some of these behavioral monitoring capabilities. The important aspect, again, as in my sort of typical crusade as a human factors engineer, is that the technologies have to be observable and to the people that they impact. And so it's okay that we know today, the three of us know there's a camera recording our voice and image. It's not okay if that camera is running when we don't know that it's running. And so oftentimes companies sort of put this, they put the sort of veil of disclosure in a little screen that pops up when you log in that says, this information system is owned by this company, and therefore everything that you're doing is monitored. And they presume that that allows them to install whatever type of monitoring technologies that they want, because they said quote unquote monitoring in this sort of fine print as the people log in. And I think that this is creating some consternation in workforces. What type of monitoring do you mean? Are you monitoring it for the sake of operating that information system? That's sort of intuitive to the user. Or are you monitoring it to identify me doing inappropriate, illegal, or maybe less than efficient things on the job? And I think people that are logging into their systems ought to be more aware of what it is it's doing and the inferences they're making.
And
very, very true.
And to build on what you just said, I'm reminded of a real world case that involved an AI system. It involved two different people, same company. One of them was a VP, one of them wasn't. They did exactly the same thing. Now, the VP, they had one response to, and on the non-VP person, a completely different response to. And so when you deal with detection and monitoring, the outcomes matter. And making AI understand the subtle nuances of human social behaviors is extraordinarily difficult for AI to do. It likes clean margins. It doesn't like gray areas very much. It doesn't operate very well in gray areas and nuances of, well, that person's matters, so we're going to treat them differently than anybody else.
I ran a research project, probably over a decade ago. My age is slipping by quickly. And it was in a we'll just say national security setting. And the idea was that we needed data on the way the people in these work groups operated, so that we could design a new workplace for them. We were going to design a new operations center. And so the researcher, from the research perspective, this is me. It makes complete sense that I'm working with a government workforce that needs to have a new workplace design that's going to best support its role, and best support the allocation of taxpayer dollars in the building of this new facility, so on and so forth. That we should be able to collect these data. What I hadn't anticipated was the level of sort of sensitivity that particular workforce had towards being monitored. This is, again, a workforce that is typically monitoring is responsible for monitoring lots of people in the world, but they themselves don't necessarily view monitoring as something that's okay for them. So in this case, what we recognized is that we needed to be very, very transparent, open and above board, very clear to everybody what it is we were going to monitor, how we were going to monitor it, what inferences were going to be made, what inferences were not going to be made, how is data going to be used, stored, shared, protected. And the more we explained the totality of the data collection that we were going to implement, the greater the buy-in was from that initially very suspicious workforce. They were suspicious for very good reasons. They were normal humans that didn't want to be compromised by sort of underhanded secretive collection that could impact their livelihood.
Absolutely.
So I think that this is a really great lesson that I've kind of taken into any of these. Again, as a human factors and a researcher, a lot of what I do is ethnographic in nature. And I always have to pause and stop and think about the people that we're collecting data on. What are they thinking about that data collection? How are they going to benefit from that data collection? When I can engineer in benefit to the people that are being collected on which the data is collected, there's greater buy-in. They are going to behave in ways that are going to be more helpful for our data collection. And I think this is something that ought to be considered when we talk about organizations implementing monitoring tools. Mm-hmm. This isn't something that just is this only to be discussed between the CISO and the CIO and the handful of security engineers in the closet that no one really even knows. And I think the more the organizations can be open and transparent, it will be an effort. And there will be explanations need to be made, and there will be complaints. And it may take longer to implement. But once you do implement it, there will be a higher level of confidence in the organization for the nature of the data that's being collected, stored, protected, and how those decisions are going to be driven based on it. And I think that's where you get this responsible and transparent and ethical use of technology. Isn't whether it's AI or not. It's just about being ethical in the way you interact with your workforce.
And
100%.
If one quick point on building on what Stoney just said, data changes over time. Although data is frozen. So once you collect it, it's basically frozen in place. But society around that data changes. So what you say, what you do in year one has one impact, but in year 30 has a different impact and is going to be taken a different way. And so what may be acceptable today, 30 years from now, might not be. And it might be a career killer. So the data collection and the ethics behind the AI that does the analysis, we have to remember that over time, society drifts, but they're still going to be mining the same data. And they're going to be mining it for entirely different reasons.
One thing that I started doing, Stoney, which is kind of like based on what you said, is for transparency purpose, I started doing roadshows because obviously as a CISO, I'm implementing a lot of monitoring tools, and definitely the response from employees is so much better if you outline to them what the tool is, what it is monitoring, and why it is useful, not only to the company, but also to them. If you can make that case, if you can demonstrate that benefit, it goes long ways. And you can see this will actually shape the relationship going forward with the workforce. The workforce sees you act in an ethical, transparent manner. They realize that there is you start building a level of trust. That's what it is at the end of the day. So very, very true here. I think there were also a lot of already very early on cases where there was issues related to ethics. I just was actually looking up one because it was the first one that I learned about. 2006, SAS got sued. SAS, the data science company in Cary, North Carolina, right? Got sued because they were using some self-built AI solution. Let's put AI into quotation marks. Who knows what exactly it was, for hiring purposes, to screen for cultural fit, and ended up, of course, with discriminating against somebody. And that was one of the first cases, and they took a very, very close look at their internal practices and actually did decide ultimately that this was not aligned with their values at the end of the day, the way they were implementing this. So I think it requires really, and like I said, it requires an effort. Like, people that are technical leaders have to start understanding this, and they have to start not just having echo chamber conversations. Because my conversation about a monitoring tool with my sec engs and the CIO, they're going to be very, very simple. Everybody is probably already halfway bought in. They're used to having monitoring tools left and right, down to the process level. So yeah, very, very, very important consideration.
And I'm reminded of Vasily Grossman. He was a reporter in World War II, Soviet Union reporter in World War II. And he was, I think, the second or third most popular reporter for the Soviet Union during World War II. The first guy to ever report on any of the concentration camps in any language. A very popular guy, very important person during the war. After the war was over, he was purged. And because of the things he said while he was reporting during the war. And so data stays the same, but society morphs around it and changes. And the values society has tomorrow may not be the values that society has today. And so data destruction, data maintenance, data control, that are all critical elements to anything to deal with ethics.
That's a great summary for this topic. If you are a data owner, you are in fact responsible for protecting the subjects that you got this data on. And it's not just about firewalls. It definitely goes beyond that. I think, like you said, data stays and data has legs. It might end up in places you've never thought it would end up in. So
yeah,
very, very true. Now, all the way in the beginning, our next topic is collaborative efforts, right? All the way in the beginning, we kind of like alluded to something. We said like, hey, in the West, we have innovative ecosystems that don't only pump money into things, but that help us leverage our strengths, knock on wood, and make smart decisions for investments, smart decisions as it comes to identifying technologies, helping them grow, and so on. So this brings immediately the questions. How can we better collaborate across government, academia? What models have you seen that work? What models should we implement to ensure we continue to have this dialogue across all these different sections of society that ultimately need to be involved in some of those decisions?
Well, I've had the fortune to be in all three, in industry, government, and academia. And, I can say that, most oftentimes, the relationship is merely contractual. The traditional way that they interact is somebody pays a bill and the others do the work. That type of transaction isn't the collaboration that that I think that you're trying to get to. I think is even warranted. I'll just sort of offer one sort of space that these groups can differently collaborate within, which is in open source communities that they provide forums in which companies, academics and government can contribute and benefit. Some of the communities in cybersecurity, like Security Onion, Suricata, Sigma, Zeek, those are actually really powerful capabilities that are free for cybersecurity workforces to use, and they are widely used. So I think that these open source communities, in particular, afford an opportunity to collaborate on improving the usefulness and or utility of these crowdsourced rules. That governance is oftentimes something that's missing in open source communities. But government groups are really good at doing governance. We're really good at spending lots of time sitting down and writing up standards documents and ontologies and things like this. Companies are really good at sort of innovating on technical approaches, but very few of them, and I'll include mine, look for ways to contribute back to open source communities. They want to sort of throw things behind firewalls and behind patents and intellectual property walls and things. And I think that there's goodness that can happen in these open source communities as a result. One of our research projects right now is looking at ways to contribute to Suricata and Sigma communities through various translations of those organically developed rules into standardized alerts that might be useful by a variety of different people that aren't just the frontline cybersecurity analyst. So anyway, that's one thought is within open source communities, I think, is a place where it's kind of right for us to collaborate.
I think it would be interesting to see collaboration between AIs. So there's many different modes an AI has to operate in, like data acquisition is a mode that it has to operate in. And up until now, data acquisition has been sort of spoon-fed by human beings, but we're getting into the world where AIs are able to acquire their own data, go out and seek it on the internet, get it on their own terms. And so that's naturally going to evolve into collaborating between different AI systems. And those systems are going to be bound by the NDAs that they operate under. Well, how do you legally force an AI to not collaborate? Well, you're going to do it through coding the AI to not collaborate. And that brings in more ethics questions. It brings in questions of how is the AI going to be used for defense or offense? How does an AI know when it's dealing with a hostile AI versus a benign AI? And I think that's an aspect of collaboration that's very interesting to me that I've been doing some research on that I don't think a lot of folks are thinking of or looking at, but I think it is going to come down to how fast can AIs interact with each other.
Okay. So on our end, obviously we are kind of Nexus, and we are involved in trying to get together academia, government, and private entities for certain type of initiatives. Like one of the things that we started doing is there's this running joke right now in the investment world. The magic word is AI and dual use. Like if you use both of these words, the money comes, right? So what we started doing is we're running regional UN AI for good innovation factories. We try to create this model where it's a win-win for everybody involved. So you have the UN that's getting the AI innovation factories. We work then locally in those regions with the innovation ecosystems, pull universities in, pull the local VCs in, the local startup incubators or whatnot, so that they can reach out to the local startups in the area and identify those that are good for this contest. At the end of the day, it's a contest, right? And help them refine their pitch, help them refine their business models, all this kind of stuff. Then they go to this context stage, and that's where then certain governments are starting to be interested in, and where we have, let's say, VCs that are either very much focused on UN or are very much focused on dual-use technology and national security context, where it basically turns into a detection mechanism for, hey, this startup is working on something that might be good for fast track or like for some other type of program that exists. Can we like invest into them and transfer the technology over to us, or are they just getting because of a VC connection that we're bringing in or local VC and investment? So that's one way that we are right now running a program. We're running this in the Baltics, and we're upgrading our engagement for the Silicon Valley Innovation Factory as well. And the Baltic program is going to cover the entire eastern front of NATO. So we're in conversations with some NATO members to reach out to their local ecosystems and start innovating this as a basically alliance-wide detection mechanism for dual-use technology and AI. The other part is, we call it Cyber Eagle. It's a basically AI proactive marketplace. So the way that works is you have, again, capital sources, the ability to detect for small to medium sized critical infrastructure their vulnerabilities, Gen AI that does the initial outreach, and then a number of, I would call them closed market space of certified and evaluated solution providers, MSSPs, or whatever, that can deal with whatever the issues are that this small to medium sized critical infrastructure sector entity has. So bringing all of those three components together. So for us, it's academia as it relates to nurturing the local ecosystem, nurturing the knowledge and bringing up a workforce, capital to drive innovation, industry to either provide solutions or to, as the source of innovation, and government to, well, number one, govern, bring regulations, bring order to chaos, but on the other hand, also identify those things that are good for our government and interesting when it comes to the national security context. So that's what I have there. Other examples, OSAC. I guess OSAC is combining industry and government, Overseas Security Advisory Committee from DSS, but it's not related to AI really. It's protecting U.S. business interests overseas. So that's what I have there.
A couple things there that you remind me of, Michael, is one is the National Institute of Science or Standards and Technology, NIST, has recently stood up a human-centered cybersecurity work group. It's or consortium. I think it's probably called consortium. And this is a nice example of the government leading a forum within which academics and industry partners can collaborate to discuss how to deliver human-centered cybersecurity tools. And I like these types of work groups because they help bridge research and practice quite well. There's low stakes. Nobody assumes that they're sort of competing for dollars or attention, but they do allow for engineering level collaborations, which I think are really important.
I love that you brought up NIST. That's a very good example. I can't believe I didn't see this earlier. That's
I'll share with you the information. I had a former colleague of mine at one of the agencies recently took a job there and stood that up. I think it's a great new organization. We're participating in that. The another, I guess, an example in your sort of challenge problem space, I think, is there's oftentimes good opportunities for the government to shape challenge problem activities. I'm running one that's data oriented. It's sponsored by the DoD. It's called the Defense Data Grand Prix, and it's a good example of not just sort of throwing a challenge problem over the fence and asking people to kind of noodle with it in private. It's set up as a collaborative competition. So the collaboration happens between a government problem owner and a faculty-led data science team, and then the competition is between teams. But the notion is that the knowledge about the problem and the data that's necessary for the analysis isn't necessarily available to academics in their own individual capacity. So you have to create these collaborative venues that encourage a government person that's never worked with a data scientist to sit down and share information about their problems with the data scientists enough so that the data scientists can bring their knowledge to bear. And so we've found some really nice success stories out of the first 4 iterations of that type of competition venue. And I think that that style of competition could translate to other, sort of, in this case, we're dealing with sort of acquisition data findings, but to cybersecurity, use cases as well.
Okay. I will say, for me personally speaking, my times on NIST working groups are probably some of the most happiest collaborations that I had in my life, just because it's multidisciplinary, all from over like all the three sectors involved, and because of what you're working on. I did the AI RMF, NIST NICE, and then, well, not directly through NIST, but I was a part of the US delegation to ISO 27000, basically. Worked on that one. Yeah, it's a standard, kind of boring. But on the other hand, it was when, privacy just became a topic. So lots of conversations between international stakeholders that then led to the monster called GDPR. But still, it was a lot of fun. Like private, like this kind of model, this engagement model is fun. And I don't think people realize that.
Well, one of the things that I'll just add as a footnote to that conversation is that a lot of times people think of these collaborations between government, academia, and private companies as like collaboration between big, well-resourced organizations, because that's usually the groups that can afford to collaborate with the government are big and well-resourced. You can't have a lot of people sitting down at a roundtable discussion if you're not making a lot of money. And what I would say is that isn't necessarily always the best source of innovations. Your innovative insights, your new novel approaches are coming from smaller companies. But the flip side is, how do you get smaller companies to be able to invest in those types of work? It's sort of, consortia or, collaborative venues. And I think what it boils down to is you have to have investors that actually value that kind of collaboration. No small business is going to do anything outside of the guidance of their investors. And so I think that if we as a sort of a society, or maybe within the government, or in some ways we manifest mechanisms to incentivize investors to value these collaborations, I think that would translate to smaller businesses getting involved with those roundtable discussions and, collaborative problem solving.
Absolutely. They have to make it profitable somehow, some way.
You got it. People weren't going to invest in green technologies if it's not profitable, and profitability can come in lots of ways. It can come in reputation. It can come in, sort of, public relations. And perhaps this is another area where we could incentivize investors by, shining light on their portfolios that are contributing to, sort of global enhancements rather than just, profits.
All right, we're running out. We have about 7 minutes left. The future.
There you go.
Yeah, I know. The future. Like, oh my God.
My favorite topic.
So, the favorite topic, the crystal ball. Each of you. What major trend relate to AI and cybersecurity should everybody be looking out for, let's say, over the next, let's give it a nice 5 years. Let's do 5 years, not like 1 or 2 years. That's 5 years. Who wants to take it first? Good luck.
I'll dive in. I think the topic is going to be on deception detection. It's going to be on deep fake analysis and detection, and explainable AI. That said, those are very hard things to solve, and I don't know that they can be solved in 5 years. So I think the trend is going to be that there's going to be a lot of research done in 5 years, but I don't think they're going to achieve success in 5 years.
Okay. Stoney?
Well, I mean, I guess fortunately we have some research projects that have that kind of time horizon in them. So maybe we're gonna succeed at delivering on our research projects. Maybe wait there. I think one of the ways that I think that one of the approaches to cybersecurity I think that you're going to see emerging just based on our initial work on this IARPA Rescind project is that you're going to see more cybersecurity applications making nuanced inferences about hackers. And by nuanced in this case, I'm particularly talking about not just identifying that there is an attacker in your network and how do you get them out. But again, it's this notion of creating the soccer field that allows for, it understands that, players are on both sides of the field, and how do you accommodate success even in spite of that. For IARPA Rescind, the Bulls Run Group is a lead system integrator under a Raytheon team on this. And the focus is delivering a psychology-based cybersecurity application. So it's the idea is that we will make inferences about reasoning strategies and identify ways to aggravate poor reasoning strategies amongst expert hackers. And this type of technical approach is just like Schaefer mentioned, is very difficult. But I think in the 5-year time horizon, we'll see some mature implementations of these approaches. Another area that I think we'll see some nice maturation in is addressing the sort of signal overload in these security work groups. Before the call, we'd kind of talked about a little bit briefly about addressing this as a problem, with false positives, but truly it's really just a signal overload issue, because uninterpretable, late, and inactionable hits are as problematic as misses. So I think that the progress of for AI models to improving the signal detection overload issues, I think we're going to see lots of advancements in there. I think there's 4 ways that you should look for, the things that we should look for that indicate that we're making progress in them. One way first is you'll see work in interfaces and architectures that allow for your users of these cybersecurity applications to make better decisions about tuning of those rules and alerts. Right now, you basically if you get it, you get a slider that says, make more sensitive or less sensitive. Nobody knows what that even means, so they're going to leave it at 50. How often have we made adjustments to any sliders? They're going to stay the way they came in the box. So, but because the sliders don't give us indications of the implications for moving the slider. So I think you're going to see improvements in this, where you're giving feedback to people that allows them to better tune these rules and alerts. The second area is really in coming up with better ways to cluster or create higher order classifications for alerts. It's no longer sufficient to just pop alerts and let people know malware is here or this is there. What are we seeing in our network? These are higher order classifications that involve not individual rule-based alerts, but we're using AI models to better characterize what's happening in the network in a natural language interpretation. The third way is we're going to see better model maintenance features for users. Schaefer just alluded to this previously. Model maintenance can no longer be the sole responsibility of the vendor, because the vendor isn't living with the consequences of the poorly maintained model. So we're going to see cybersecurity tools that allow people that are using the applications to maintain those models in ways that make sense for their organization. It may still involve feedback into a vendor's corporate architecture, but it's going to allow for better control and knowledge about those models and how they're limited or not limited by their design. And then the fourth way that you're going to see improvements in this, really what I consider bin of human-machine teaming improvements, is that you're going to just see better trained models. You're going to have better data that's used, but more importantly, the better training will also come from reinforcement learning that's done in production. So this is different than the model maintenance, which is some sort of active interaction with the AI model, but allowing for the models to be revised in production rather than having to go back to the vendor for model retraining. You're going to see these alerts and sort of signal overloads be improved through through just direct interaction with the software itself while it's in production.
Well, gentlemen, on that note, it was a pleasure. It was an honor. Thank you so much for this conversation. I think this topic is so big. Again, you could host actually a series of events about each of the individual pieces we're discussing on, with multiple panels on this. So thank you so much. And to our audience, thank you for joining us today.
Thank you so much.
Have a good day.